Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we're looking at stretching graphs. Now, stretches are types of transformations, and by using transformations, we're able to sketch the graphs of complex functions just by adjusting the graph of a simpler function that we already know how to sketch. A stretch of an object either stretches that object in the y direction, up or down, vertically, or in the x direction, left, right, horizontally. Or you can have a stretch that does both things. A stretch does change the shape and size of an object. Stretches in the y direction, first of all. If you have y equals a f of x, that just means some constant times by f of x. That will stretch the graph of f of x vertically with a scale factor of a. So for example, if you had 2 times f of x, that will double all the y values and move every point on the graph of f of x vertically twice as far from the x-axis. The horizontal distances won't change at all. So for example, if you had f of x equals x minus 3 times x plus 4, have a go at sketching the following on the same set of axes. First of all, the original function, then 2 times the function, and then half times the function. Pause the video, have a go, and come back to me when you're ready. Okay, let's have a look at these. So y equals f of x, first of all, it's just a quadratic. It's a normal way up, right way up quadratic. There'll be a crossing point in the x-axis at +3 and at -4. So crossing points here and here. And to find the crossing point on the y-axis, we let x equal 0. If x is 0, we'll have -3 times 4, which is -12. So there'll be a crossing point here as well. And the function will look something like that. We're then asked to sketch y equals 2f of x. Well, that doubles all of the y values. So the -12 here is going to be doubled to get -24. Now the y values here and here are 0. And when you double 0, you still get 0. So points on the x-axis, they're not going to move at all. So the new graph is going to cut through -4 and +3, but it'll also come down here at -24. That would be the equation of the new function. 2f of x just means double f of x, and you get 2 times x minus 3 into x plus 4. And it would look something like that. Part 3 asks us to sketch y equals 1/2 of f of x. Well, that'll half the y values. So we'll have 1/2 of -12 is -6. If we had to write the equation of that, then you just put 1/2 in front of the function. So 1/2 into x minus 3 times by x plus 4. And it'll halve the y values. So we'll get this crossing point here at -6. It will not affect these two values because you just get 1/2 of 0 is 0. So the new curve, again, will cross at -4 and +3, but this time it'll go through -6. And you'll get something that looks a little bit like that. Stretches in the x direction are slightly more confusing. As with translations, the opposite thing happens to what you would expect when you adjust the x values. So y equals f of ax. So we're multiplying the x values by some constant a. That stretches the graph of f of x horizontally in the x direction, but instead of timesing by a, you actually divide by a. So for instance, if you had f of 2x, that'll move every point on the graph of f of x horizontally, but not twice as far from the y-axis. You divide by 2, 1/2 as far from the y-axis. The vertical distances, those don't change at all. Okay, second example, it's another quadratic. Have a go at sketching the quadratic, and then try and sketch f of 2x and f of 1/3 x. Have a go yourself, pause the video, and come back to me when you're ready. Okay, let's have a look at these. So the original function is again a quadratic with a crossing point at +4 and -6 on the x-axis. If x was equal to 0, then minus 4 times 6 is minus 24. So there'll be a crossing point here at minus 24 on the y-axis, and the curve will look something like that. F of 2x, well, first of all, what would the equation be? They haven't asked us that, but just so it's clear what's going on, the x's all change to 2x. So wherever we have x in the original function, it's now going to change to 2x. So that would be the new equation for f of 2x. 2x minus 4 times by 2x plus 6. Now, the consequence of doing the stretch is the opposite from what you would think. So instead of doubling the distances from the y-axis, we're going to halve the distances. So a half of minus 6 would give us minus 3. A half of 4 is 2. This is on the y-axis. A half of 0 is 0. So this point will still be on the new curve, but these two are going to change to minus 3 and 2. And if we join all those together, we get something a bit like that. If we had to do f of a third x, something very similar happens. First of all, looking at what would happen to the equation of the function, the x's would just change to a third x. So we'd get that for the equation of f of a third x. In terms of what happens to the points, you do the opposite thing when you adjust the x values. Instead of dividing by 3, we're going to have to times by 3. So we'll get 4 times by 3 is 12, minus 6 times by 3 is minus 18. And we'll get crossing points here and here. Again, the point on the y-axis, that doesn't move, so we'll still be going through minus 24 on the y-axis, which will give us something a little bit like that. Now, there is a special case when a equals minus 1. So there are two possibilities. If you have y equals minus 1 times f of x, that doesn't change the size because the scale factor is 1, but its effect is to reflect the graph in the x-axis. So y equals minus f of x, a reflection in the x-axis. If you adjust the x value so that you get f of minus x, that'll reflect the graph, but in the y-axis. I'd make a quick note of those if you don't know them already. Okay, let's have a look at an example. Again, we've got a quadratic to draw. Once we've drawn it, then have a go at sketching y equals minus f of x, and then have a go at sketching y equals f of minus x. Pause the video, have a go, and come back to me again when you're ready. Okay, let's have a look. Once more, we have a quadratic. Crossing point on the x-axis will be plus 2 and minus 4. Here and here. If x is 0, then we'll have minus 2 times by 4, which is minus 8. And sketching the curve will give us something a little bit like that. If we have y equals minus f of x, now that's a reflection in the x-axis. Now, points on the x-axis, they're not going to move. So minus 4 will stay at minus 4, 2 will stay at 2. But this point is going to reflect in the x-axis. Minus 8 will reflect upwards and become plus 8. In terms of the equation, the new equation will just be the original one, but with a minus in the front. And 8, that's where minus 8 will reflect up to. So it'll go through minus 4, 8, and 2. It's an upside down quadratic now. We'd have minus x squared if we multiplied out those brackets, and you would get something that looks a little bit like that. F of minus x is also a reflection, but a reflection in the y-axis. In terms of the equation, all the x's will change to minus x's. So that would be the new equation. That would be the equation of f of minus x. In terms of what it looks like, the minus 4 will reflect in the y-axis and become plus 4. The 2 will reflect in the y-axis and become minus 2. And you'll still get a crossing point at minus 8 on the y-axis. So minus 2 and plus 4 and minus 8. It's a right way up quadratic. If we multiplied out the brackets, we would get plus x squared. So you'll get something that looks a little bit like that when you reflect it in the y-axis. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 74 and have a go at exercise 4E. Thanks very much for watching, and cheerio.